Hi everyone, welcome to our video for physics. Again, back to physics, Pathfinder Fusion Physics. So in today's lesson, we're going to look at a topic that you have learned since secondary 3. So if let's say you have just started secondary 3, this will be the right video for you to watch. If you are already in secondary 4 and you have a lot of confusion on this topic called kinematics, then this is also the right video to watch. Okay, the thing is that I cannot just shoot one video for kinematics. I will have to bring in some concept related to dynamic or forces. So remember there's the first few chapters that you learn is on forces. So this is the thing that we're going to talk about as well, as compared to just kinematic alone. Because in reality, the truth is that when we look at the object that's in front of you here, right? Imagine if you throw a ball up into the air. Or you are talking about playing catching with your friend. Or last but not least, you want to explain how come this car can actually move faster than the other car. All these are basically object in motion. But the thing is that right, when we talk about object in motion, we can use things to describe them, like such as how fast will be speed, how far will be distance, and of course, how long will be time. So all these are quantities that you use to describe or compare when something is actually in motion. But the thing is that to really explain why it changes, we have no choice but to use the concept that is borrowed from the idea of force. Because force is the way we interact with every single thing around us. You push an object, the object moves. You pull an object back, the object moves towards you. Okay, you use a force to push against an object, the object will turn around. So the effect of force, something that you learn in primary school, is still relevant. But in secondary school, we're going to go one step further to not only talk about what are the things that happen, but we're going to look at the magnitude of things that's happening. That means to say how much. Okay. For those of you who are interested to know a little bit more about this topic, okay, feel free to let me know. I can share with you some notes that I have prepared on my own. And of course, just to share at this point, I will be publishing a book, okay, soon on related to the science of physics. So if let's say when you go to Popular and you see my book, okay, feel free to pick it up. And if you are a subscriber on my video, I will be able to share with you some discount as well. Okay. Anyway, let's come back to the topic. So the thing is that when we talk about speed, distance, and time, these are really quantities that is being used to describe motion. So quantities in kinematics is all these things that I just mentioned. And of course, for some of you, you might have learned that actually speed can also be known as velocity. Then distance can also be known as displacement as well. So these are things that give you a direction, apart from also describing almost the same thing, how fast, how slow, and moving in one direction, how much distance is covered, so on and so forth. Yeah. But if you're really looking at explaining why the motion changes, right, you should be looking at force. So I have a picture here to use to help me to describe the concept of velocity, displacement, and acceleration. And this diagram that you see here is a very common diagram you get to see in the exam as well. So like for example, if you throw a ball up, then I will say that there is an upward velocity. Or sometimes you might say that this is a positive velocity. Positive. Because why? I'm moving up. So most of the time when we look at it, right, any object that's moving up will have a positive velocity. You can use this convention. It is normally okay for you. It's useful for you. But the thing is that while you're moving up, you also notice that I'm actually slowing down at the same time. So in this case, right, the object is known to be decelerating. And of course, this is all thanks to this thing called the weight of the object. The weight will be pulling it down, causing it to decelerate. And when you are decelerating, then in this case, you can think of it as a negative acceleration. So when you see the word negative, it means to say not really always down or left or right or up. Basically, the direction is given by the negative sign, but it just means to say it is opposite to the positive motion. The positive direction is opposite to that. So in this case, if I'm going to say that upward is positive, then having a downward acceleration means I'm slowing down and actually traveling opposite to that direction. So usually negative has the meaning of opposite to the original direction. That is provided the original direction is positive, of course. If the original direction is negative, then this actually does not mean a deceleration. So at the end of the day, right, if your acceleration is in the same direction as the object's motion, like for example, you're moving like that, this is A, right? Then this is accelerating. And of course, it is as per what you have understood so far is that accelerating means going faster. So this is going faster. But if let's say your object is going to the right, your A is to the left, then this is called deceleration, or you're actually decelerating. You are slowing down. Okay. Then how about displacement? Yes, displacement is a way to describe how far you have traveled, but not just telling you like the distance only. It's also at the same time, right, trying to tell you which direction do you head. So let's say you have a negative 10 meter, right? In the context of this question, it means to say that you have went down from where you started, let's say this horizontal level. Okay, you are 10 meters below where you started. So in this case, this is a downward displacement. So displacement, very importantly, you need to have this thing called the start. And then you need to know this thing called the end point. Where do you start? Where do you end? You find the shortest distance. Okay, remember, this is the shortest distance between the two objects. Reason why I need to point this out to you is because that if you're talking about throwing a ball up and then coming back down, you do not consider the upward journey. Because your start point is here, your end point is probably somewhere below, then to find displacement, right, you actually find the distance between this start and end point. No need to consider the upward journey, because remember I said it's the shortest distance. But if you're talking about the case of distance traveled, okay, I use a different color, your object will have went up and then come back down to the bottom. So you have to take account the entire journey that is being traveled to find the actual total distance traveled. Okay, so in a class itself, maybe your teacher will show you, oh, imagine you move from left to right. So you start from here, you move to here, but you can actually be taking this path to come to here, this path to come to here, but they all have the same displacement, which is true, because displacement is a matter of where you start, where you end. I take a measuring tape and measure them, how far are they apart, and which direction you headed. So you move to the right, then that's positive. You move to the left, then that's negative. But this is only one possible convention. Please don't take my word for it. This is the only way, no. Okay? So if you ask a science teacher, right, they will tell you that, yeah, there's actually more than one way to do this. But for the sake of making it simpler for you, take right as positive, up as positive. I think that is good enough. Okay? So with that, we come to the next part, which is talking about graph. Graph is very useful because graph basically tells you the motion for the entire journey, or at least for a substantial amount of time. So this is a good way to look at the overview of what happened to the object. So often you will be asked to draw three types of graph, whereas the displacement and the velocity is almost 90% of the time, but acceleration, sometimes you will need to get to know it. So what you need to remember from this page over here, right, is that the displacement time graph, okay, what are the things that I can get underlying to it, right, will be the gradient of the displacement time graph will be giving you the velocity, the rate at which you are moving, how fast. So I will say that I will borrow one concept from the E-math topic, which is called the tangent of the graph. So when you draw a tangent, meaning you say the line cuts through your graph at one point. Why is this important? Because that can help you to get a visual aid to help you to see what exactly is changing to the gradient. So let's say over here, right, I draw a tangent here. Okay, I try to draw it straight because I don't have ruler here. Okay, then for a person that understands the idea of gradient, which is the slope of the graph, you can see that these three red color lines that I drew, they all have different gradient. And starting from the one on the left, which is this one has the lowest gradient. The stiffness of the slope is actually the lowest. Then you look at the last one, which is over here. This graph actually has the greatest gradient, is the steepest. So which means to say that this object is actually accelerating because the velocity is increasing. So now if I ask you to copy to a velocity time graph, right, just make sure you draw a graph where the gradient is positive and its velocity keep increasing, getting faster and faster. But the thing is that we cannot tell from the displacement time graph what exactly is the acceleration. But you can tell from the velocity time graph what is the acceleration. So for the gradient of the velocity time graph, this will give you the acceleration. You can get it. And you might be thinking, how do you really remember gradient is what and area under the graph is what? Actually, I always teach my students to think of this in a very simple manner. So think about this. To find gradient, we have to find the change in y over the change in the x. This is borrowed from math again. And remember that in the case of the velocity time graph, the change in y is really the change in the velocity. And you take that divided by the change in time, wouldn't change in velocity over time be equals to your acceleration? Correct? So then next, if you want to remember like what does the area under the graph represent, right? So the area under the graph here is by taking a half times base times height, isn't it? And not forgetting your base and height is really your, okay, base is like your time here, then your height is really your velocity. So velocity times time or speed times time gives you distance, isn't it? But now it's displacement. So this is velocity, then it will give you displacement. So yeah, speed times time is distance, or velocity times time is displacement. So use this idea to help you to remember what exactly does the quantity represent. Okay, this will really help you in a lot. But for the case of the acceleration time graph, if you want to draw, right, then basically you need to figure out the changes in the acceleration from the velocity time graph, and then you move on to talk about the acceleration time graph. Okay, but this graph, actually, I will always feel that the usefulness of this, right, is to relate to the net force. So in this case, if I see that the acceleration is constant, but there is an acceleration, then I will know that my net force is equal to constant. That means to say no change. The force acting, basically. Because the force, according to Newton's second law, F equals to ma. This is the part where I need to borrow from the topic of force. So according to Newton's second law, the force, the net force is directly proportional to the acceleration, provided your mass is constant. So in this case, if I see that the constant acceleration, I know that basically the net force should also be constant. So with that, I will get some idea of how the force is changing with time. Okay, so in the last part of this video, I'll also be talking about how we can use a graph to help us to better understand why the things happen in a certain way, and of course to use the idea of force to explain the main thing about the changes in the shape of the graph. Okay, let's do some simple practice. Okay, see whether you can do it. I purposely leave this blank page for me to draw any graph, and then we try to convert together. Okay, I'll do two for you. So let's say the first one, right, you have the velocity time graph. Common one that you see in the exam. So this is 10, this is 5. And then this will reach until 10, this will reach until negative 10. So now with that, I want you to try converting this graph to a displacement time graph now. Okay, you can try it now. So of course, I will wait a while, then after that, I will go to the displacement time graph, right? Or you can pause the video and you try first, right? So, okay, so this is the velocity time graph. Then next, I will draw the displacement time graph, okay, at the bottom. So this is set 1. I leave a blank here. So set number 2, let me draw a displacement time graph. Okay, meanwhile, you can try the first one first. So my displacement time graph will be like that. Okay, so this is, at the start, the thing is increasing, and then eventually it becomes constant. Okay, so now while you are doing it, while you are thinking about it, actually if you remember the relationship between displacement and velocity. Okay, you can use that to help you, because it's either we are working in the backward direction or the forward direction, but the relationship will not change. Which the relationship is the velocity is the rate at which the displacement change. So which means to say that, right, what I can say is that, right, if you look back at the velocity time graph, also we talked about it just now, the area under the graph gives you the displacement. Displacement. Right, displacement. So now if you look at the graph, right, I expect the displacement, because I'm moving, the displacement should be increasing, right? So now if I were to draw the graph for displacement time graph, let's say this is d meter, this is t second. So my displacement is increasing, and the rate at which my displacement actually increases because my velocity increases. So meaning to say that, right, I will be expecting a graph that shapes like this. Okay, like that. So if you were to draw tangent to this graph, right, you will notice that the gradient of the graph is increasing because my velocity is increasing. The rate at which my displacement increases actually increases. But then after that, what happened is that, right, the next part, I started having a negative velocity. So on the displacement time graph, the gradient is the velocity and it should be negative. So instead of upward sloping, now I will do a downward sloping. Like that. And you will end back at 0. Okay, notice that this is displacement, right? Because if you look at it, I have deliberately picked this graph so that these two parts, right, the two triangles is actually the same size. Because I said that for 5 seconds you increase to 10, for the next 5 seconds you decrease to 0 from negative 10. So the two areas under the graph is in fact the same. And as a result of that, if you take the positive displacement, this is positive displacement, plus the negative displacement, did you actually notice that they will add up together to be equal to 0? Of course, this is provided that the area is the same. So what really happened in this question is that you walk forward, then you walk backward, back to the same point. But you look at the two areas, you can see that if the area is exactly the same, then you have walked the same distance, but just one is forward, one is backward. Okay, let's go to the next one, which is the displacement time graph. How do we change to the velocity time graph? Once again, take note that the gradient of the graph gives you the velocity, and eventually the gradient becomes 0. If you are familiar with a horizontal line graph, you will know that, yeah, the horizontal line graph actually tells you that the gradient will be 0. So now if I were to draw the velocity time graph for this, it should be starting from some positive value. Notice there's a gradient here. If I draw a tangent, there's a gradient there. So which means to say I did not start moving from 0. So which also means to say that I will have a velocity at the start, and then I will start to decrease until it became 0 at the end. So at this point, right, let's say this is called 5 seconds. So at the 5th second, actually my gradient becomes 0. So notice it's the gradient, okay? If you cannot remember, cannot see, then please draw the tangent on the graph. Then you will be able to understand that how the gradient is changing. Okay, so a simple example of these two types of graph sketching. Right? I think it's very important that you know how to convert between the two. I would say that if let's say you have problem visualizing and understanding what the quantity means at the same time, maybe practice writing down the quantity first. The displacement time graph, gradient is the velocity. Okay, how to see gradient? Draw tangent. Okay, borrowed from EMF. Then after that, right, talking about velocity time graph, got one more thing. Can find the displacement or distance if it's a speed time graph from the graph itself by taking the area. Okay, so keep this in mind and do this every time you are doing it, right? Just write down the quantity first, what does that mean? Then before you do the question, you might find it easier. Okay, so over here, there's a question here asking you to sketch. This is the displacement time graph. So sketch from the displacement time graph. Okay, the velocity time graph. Okay, so you are given a displacement time graph and sketch the corresponding velocity time graph. So now if you look at the next slide, okay, I have already prepared a xy axis for you. So remember, the gradient gives you the velocity. So the first part, the gradient of the displacement time graph is constant. So what I'm going to do is that I'm going to draw a horizontal line that will stop at 20. Okay, positive gradient, right? So it's on top. Then after that, for the 20 to the 30th second, right, actually you did not move, right, because the displacement is 0. So let's draw a dotted line, and for the next 10 seconds, it will just be like that. Okay, and eventually from 30 to about 40 seconds, you are traveling in the opposite direction, because over here, okay, you can see from here, so this is a negative gradient. Okay, gradient is velocity, right? So you are traveling in the opposite direction, but constant. So for the next 10 seconds until 40, the graph will appear here. And then eventually when you go to the 40th second, right, it will become 0 again. Okay, so far so good? So you might think that, okay, one of the problems that you will face will be, right, when you are drawing graph, a lot of times you will be very tempted to draw according to what you see. You just want to copy. But please remember, don't copy the graph. Think carefully what exactly is the relationship between the two quantities you are trying to draw before you draw it. Otherwise, you will end up copying the same graph without you knowing, which is not supposed to be the case. Okay, another common thing that you will get to do in the exam will be describe the motion of an object. Okay, so this is from 0 to the 10 minute. Okay, so this is a ship. And the question asks you to describe. So first of all, look at the graph that you're looking at. This is a speed time graph. So meaning to say that every single point is talking about how fast your object is moving. Okay, and whenever you see a straight line like that for your speed time graph, okay, a one that is oblique, going upwards, this means to say you are gaining speed, and this is a constant acceleration because this one is constant gradient. Gradient of the speed time graph is actually your acceleration. Then after which, constant acceleration, this part, are you moving? Yes. A lot of people say not moving already, but no, you are still moving because you have a velocity or speed 2, right? You are still moving, but constant speed. So this is constant speed. Then after which, at the C section, okay, C section, this is the part where your speed is increasing again, but relative to the first part, you notice that it's more steep, right? So which also means to say that acceleration has changed, something that you can point out in your answer. And of course, last but not least, coming back to the horizontal again, you did not stop, you are still moving, but just now you move faster. So this will have been my answer. Okay, very long. So in the description, right, just take note that you need to mention the time frame that you are describing, what exactly is happening. Use words such as acceleration, velocity, distance, displacement to describe. Do not just say, oh, I think it's moving, not moving, and then very vaguely you talk about it. And of course, if let's say you have a graph where the values can be gotten from the graph itself, right, please try to use the value that you have gotten to describe it. So I started from talking about 0 to 3, traveling at a constant acceleration, and then the speed increased from 0 to 2. Then from T3 to 5, the ship is traveling at a constant speed. Okay, no change in speed. Then from 5 to 7, the speed is traveling at a greater constant acceleration, but from 2 to 10. Then after that, last but not least, 6.5 meter minute onwards, right, you travel at a constant speed of 10 meters per second. Actually, my second part here, I should mention constant speed of 2 meters per second. You can also include that. Yeah. Always when there's value given to you, just write down what you are given as well. So this shows that you understand the graph. You have interpreted the graph itself. Okay, last part of my video, we're going to talk about how Newton's laws of motion is being used to explain a question like that. So this question, or rather this graph, I think you might have seen it at least more than once. Sec 3 also should have seen it. Sec 4 also should definitely have seen it. So they ask you to explain in terms of force acting the shape of the graph. So first of all, right, you can see that the graph is increasing in speed, getting faster. This is a falling object. You drop from a certain height. So speed is 0 at the start. Then after that, it becomes faster and faster, and eventually, at some point, it becomes horizontal. So this is because that apart from the thing that's pulling you down, which is the weight, some of you might already know, there's also this thing called air resistance that's going against it. But air resistance is not constant. Air resistance is something that changes with time. So this is the reason why the graph shape will not be very consistent. In fact, it consistently decreases in the way that the gradient is actually on the graph itself. The force is acting, so that one changes. Because Newton's second law says F is equals to ma. So as you move faster and faster, the net force actually decreases, because the net force here, as you can see from my diagram here, right, is given by weight minus away air resistance. Because as you move faster, the air will act against you more. Alright? And then eventually what happens? The air resistance will be equal to your weight. And this is the point where you stop accelerating. In the pure physics syllabus, this is known as terminal velocity or terminal speed. But even for the combined science student, I think this is something that you might want to learn as well, because times and time has been proven again that you really need to know your concept between motion and force. They are related. So you cannot say that you don't know there's air in this world, right? You definitely need to know. Okay, so how do we explain this question? When an object is falling from a height, its speed increases and the air resistance increases. So pointing out that the air resistance is not constant, right, is something that's very important. The relationship between the speed and the air resistance acting. And after that, link to the Newton's second law to say that the net force will be decreasing until 0 eventually, but decreasing first. Then when the weight is equal to the air resistance, or you can say net force 0, this is where your object will travel at a constant speed. And this constant speed is known as your terminal velocity. Okay, that will be the last question on my slides already. And I just want to give you a very good idea of kinematic, starting from the very basic about understanding the quantity, use them to describe the motion, and then after which I show you how graphs are being sketched, which is probably one of your weakest points. But this one comes with practice, so I would suggest that you can do like what I did just now, draw some random graph or pick some random graph and then start sketching, converting yourself. And last but not least, of course, this is a science question. You still need to be able to understand as well as explain. So, but the explanation part in kinematics really came from the next topic, which is the force part. We're using force to explain how motions are changed. Alright? Okay, that will be the end of my video. I hope you like and subscribe my video, as well as help me to share with your friends. So this is the kinematic topic. And in the next topic that we're going to go through, I will move back to something else. So I will try to vary between the different parts of the topic. So first part, we talk about the electromagnetism part, right? So this is the second video where we talk about the general physics, okay, talking about kinematics and forces. And in the next video, probably we should dive into something related to wave or even heat. So these are different aspects, just to give you a flavor of what are the things to expect. And I will try to pick the topic that is the most important to you and you feel the most confused about. So at least after watching my video, you can level up a bit, and then when you go back to do your work, you will be better able to understand how to get on. So this is to give you a start point, but this is by no means the end. Alright, so I will record more video in the future as well, but however, you need to do your part as well. After watching, go and review some questions from your assessment book or TYS. Then after that, come back to watch the video one more time, and then you will be better understand what exactly is going on. Okay, thank you guys. I will see you again in the next video.